So today we start our work on vectors. We're just doing a little unit, 3 sections, just a quick introduction to what a vector is. A vector, it's pretty much like a ray in geometry, where it starts at a point and then goes in one direction, but it doesn't go forever. It has what we call a starting point and an ending point. And it also has what we call magnitude, and direction. The magnitude is just going to be like the length of the arrow, and the direction will be corresponding to some degrees. We're going to get more into that tomorrow. Represented by an arrow or a ray drawn from one point to another. And we name a vector either like this little baby V with the arrow over it, so like vector V like that, or we would say vector AB. Like a ray in geometry, but knowing that that B is what we call the terminal point or the end point of it. We can write vectors in component form, where X represents the horizontal change. It'll probably make sense to you that if the X is positive, that means right and negative left. And then the Y represents a vertical change. And it will probably make sense to you that positive is up. I was just going to do an arrow there. And negative is down. It looks like an ordered pair, but it's not an ordered pair. It doesn't plot a point. It expresses the horizontal and vertical change from the initial point to the terminal point. So here I have a vector CD. And if I wanted to write the component form of CD, it would be this bracket and then 2, 3. Not the ordered pair 2, 3. The 2 represents a horizontal change, I guess, of 2, and then the 3 represents the vertical change of 3. And obviously you can see that we got a right triangle, so that's going to come into play too. So write the component form of each vector graph if needed. So A is 1, 2, and this is going to be a little hard for me to draw, but there's the A, and then -3, -3, there's the B. So there's my vector. If I want to do the component form, I always do the horizontal change first. 1, 2, 3, 4. So that looks like it went left 4, 1, 2, 3, 4, 5, down 5. Component form of the vector. Try the next one. CD, -1, 5 is up here. There's C. And then -1, -4 is D. So this vector goes straight down. So because it goes straight down, does it have any horizontal change? You are right, it does not. Does it have a vertical change? 1, 2, 3, 4, 5, 6, 7, 8, 9. It went down 9. This one's nice because it's drawn for me, so I got to do the horizontal change. Looks like 1, 2, 3, 4. So it went right 4, and then 1, 2, 3, down 3. Horizontal change, vertical change, not an ordered pair. We can also write vectors in what we call an I and J form. So the I is the horizontal component, just going to abbreviate that, and the J is the vertical component. So if and then the vector here, if it was written in component form AB, we change it to I and J form AI, like that. So here, if vector U is 7, -4. Now here's a fun fact. Vectors don't have to start at any particular spot. You can start this vector that goes right 7, down 4 anywhere. So maybe I start it here. Start it at 0, -5, 0. If I go right 7, down 1, 2, 3, 4, there's the vector. If I had started it at a different spot, it would still be considered the same vector because it still went right 7, down 4. Or in terms of I and J, it's 7I minus 4J. 5, 3. A lot of times I like to start vectors at 0, 0 if I can. So it goes right 5, up 3. There we go. There's the vector. 5I plus 3J. And then finally -4, 6, maybe I'll start that like down here just to have room for it. -4, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. There's the vector, and it's negative 4i plus 4j. And again, if someone drew that same vector with a different starting point, it would still be considered the same vector. Now we're going to add and subtract vectors. It's going to be very logical. You're going to add the horizontal changes and add the vertical changes, but there's also a graphical component to it. So basically, if I'm going to add vector A here plus vector B, I could just add them and get negative 2, 0, which is the answer, but I want to show you graphically how that looks. So we're going to start at any point. I like to start at 0, 0, and do vector A by going right 2, up 3. So here is vector A. Like that, I'll just do an A. And then vector B, then we will start, when we're adding them, we do it tip to tail. We start vector B at the end of vector A. So starting right there, we're going to go left 4, 1, 2, 3, 4, and down 1, 2, 3. And then connect those dots. That's vector B. Vector A plus vector B is the vector that completes the triangle. And you can see that that's negative 2, 0. Also, we could get that because 2 plus negative 4 is negative 2, and then 3 and negative 3 adds up to 0. So we could do it without drawing the picture, but we want to draw the picture, if that makes sense. So try another one. Negative 4, negative 3. Again, I can start it anywhere, so I'm going to start it at 0, 0, down 4, right, left 4, down 3. There is vector B. And then tip to tail, I'm going to do vector C, which is right 1. Okay, so now I'm like, oh, I'm going way off. So maybe I'll start vector B somewhere else so that I can do it. So maybe I'll start vector B up here. 1, 2, 3, 4, 1, 2, 3. It's still the same vector. It can start at any spot. So there's vector B. Now I'm going to take vector C, which is going to start here and go right 1, and then down 1, 2, 3, 4, 5. So there's vector C. Like that. And then what we call the resultant vector is the last part of the triangle. And so you can count it, or you could also go back to just adding the components together. Negative 4 plus 1 is negative 3. Negative 3 plus negative 5 is negative 8. And it should match. And I don't always make you draw the picture, so like here for this one, negative 2a is just going to be what you think. You just distribute a negative 2 through vector A, and then 6c is just going to distribute a 6 through vector C, and if I add those together, I'm going to get 2, negative 36, and that would be a tough one to draw anyway. Don't have to draw it. Another twist on this is if vector V is 4, 7, and the initial point is negative 4, negative 5. So this is actually not even adding vectors. This is kind of going back to component form. So the initial point is negative 4, negative 5, and then the vector is 4, 7. So it goes right 4 and then up 7. So find the terminal point is, now this is an ordered pair, 0, 2. Right? Okay, last thing, multiplying vectors. Multiplying vectors follows a formula, and it's called the dot product. The dot product between two vectors, a1, b1, and a2, b2, is a1, a2 plus b1, b2. We'll talk about orthogonal in a second. So if I want to multiply those two vectors or find the dot product, it's 3 times 1 plus negative 5 times 4. Or 3 plus negative 20 is negative 17. Here, 6 times negative 1 is negative 6, plus 2 times negative 2 is negative 4, is negative 10. That's all it is. Now here, 1 times 12 is 12, plus 6 times negative 2 is negative 12. That answer is 0. If the dot product is 0, this means these vectors, and I don't have room to draw the picture, but you'll draw one on the homework and see they are perpendicular to each other. If the vectors have a dot product of 0, they're perpendicular. I wonder if I could just barely draw one. Like if I went right 1 up 6, like that would be like vector u. And if I started at the same point and went right 12 down 2, that would be vector v. They would be perpendicular to each other. Only if the dot product is 0. Here the dot product is 7, so they're not orthogonal. And that is your quick introduction to vectors.